This is Subhash, Aptitude trainer from DURGASOFT. Today we are discussing one of the very important topics of reasoning, which is cubes. We know there are three important topics: cubes, calendars and clocks. We say three C's. Out of three C's, one C is the cubes. This is very important question. All MNCs are asking a question from cubes. Let us start with the basics of the cubes. First of all, what is cube? Cube, in the sense, actually we have the idea about the cube. It is 6-faced 3D figure. Each face in the shape of a square. There are 6 faces of the square shape, and it has 8 corners, 6 faces and 12 edges and 8 corners. It is a cube. But not only the cubes, in the cubes topic there may be cuboids. All the solids are also taken in the cubes. Cylinder also considered as a cube, especially in the reasoning cubes. Even cuboid also considered as cube. So the in topic cube we may get all the different type of solids. Then what type of the questions are asked in cubes? Actually this is also called as cube cutting. We can call this also cube cutting. What is cube cutting? Let us take an example to understand better. On your birthday occasion, you are given a cake. Say this is in the cuboidal shape. In cuboid shape a cake is given, and you are provided a knife. And you are asked use one cut. This is your birthday cake and you are given a knife and asked to use only one cut. How many equal pieces can you make this cube? Equal number of pieces. How many equal pieces can be made by using one cut of a cake? So we structurize like this. Here number of cuts and minimum number of equal pieces and maximum number of equal pieces. When you are allowed to use only one cut, this is your birthday cake and you are using only one cut, then how many equal number of pieces can be made? If say this is a one birthday cake, you have to use only one cut. You may cut like this. So there are going to be 2 equal number of pieces. So minimum number of equal pieces are 2. And what's the maximum number of equal pieces? However you cut, you are going to get only just 2 pieces by using the single cut. Number of cuts is 1. Then you will get only 2 pieces. It may be minimum or maximum. So you will get maximum number of pieces also 2. If you are allowed to use 2 cuts, how many equal number of minimum pieces will you get by using 2 cuts? If this is a cake, you can use your knife like this. This is a one cut and this is a other cut. So you are getting 3 equal number of pieces. If this is your cake surface, you can use one cut like this, you can use one cut like this. So 1, 2, 3. 3 equal number of pieces you can get. So minimum number of pieces is 3. And what could be the maximum number of pieces? How can you get the maximum of pieces? If this is your cake, to get maximum number of pieces, how are you going to do this? Say for example, this is the cut 1. You got it into 2 pieces and use another cut like this. This is the cut 2. Total how many pieces it is made into? 1, 2, 3, 4. Here when you are using the 2 cuts, you can get 4 equal number of pieces. This is a cut 1, cut 2. You are allowed to use only 2 cuts. If 2 cuts are like this, cut 1, cut 2, you will get 1, 2, 3 pieces. 1, 2, 3 pieces. If you use the 2 cuts like this, cut 1 in this direction, cut 2 in this direction, you are getting 1, 2, 3, 4 pieces. So maximum number of pieces are 4. And if you are allowed 3 cuts, you are allowed to use 3 cuts. Then how many pieces will you get? If this is the cake surface, you are using 3 cuts, cut 1, cut 2, cut 3. So 1, 2, 3, 4. You will be getting 4 equal number of pieces. And how many maximum number of pieces can you get if you are allowed to use 3 cuts? 1 cut you can do like this, you got into 2 equal pieces, and this is the second cut, you got 4 equal pieces, and use another cut like this, another cut horizontally. By using the 2 cuts, you got 4 pieces, again 4 pieces cut into horizontally, that you are going to get totally 8 pieces. So this is how the number of cuts and equal number of pieces minimum and equal number of pieces maximum. By observing this, when you are using 1 cut, you will get 2 minimum number of pieces and 2 maximum number of equal pieces. By using 2 cuts, you can get minimum number is 3, maximum number is 4, and using 3 cuts, minimum number 4, maximum number 8. This practically we have seen, but in the real time exam, if it is asked how many minimum number of pieces can you get by using 6 cuts of a birthday cake, then what is going to be your answer? And how many maximum number of pieces can you get by using 6 cuts of a birthday cake? The cake is considered as cube, that's why this is also called a cube cutting. Then to understand this, instead of that visualizing practically, you can remember a formula for this. The easiest thing is, if you find the relation between the number of cuts and the output of the minimum number and output of the maximum number, you can create your own formula. Just what's the relation between 1 and 2, 2 and 3, 3 and 4? It's very clear, this number is 1 more than the number of cuts here. So if number of cut is considered as n, then the minimum number of pieces is going to be n plus 1. Is it clear? If the number of pieces is, number of cuts is 1, then minimum number is n plus 1, means 1 plus 1 2. If the number of cuts is 3, the minimum number is 3 plus 1 4. If in the real time exam, if it is asked how many equal minimum number of pieces can you get by using 6 cuts, as we know n plus 1, 6 plus 1, 7 is going to be your answer for minimum number of equal pieces. And what about the maximum number of pieces? Again, try to find out the relation between the number of cuts and the output of maximum number of pieces. If this is 1, then maximum number is 2. If 2 and there is 4, if this 3 and there is 8, what is the relation can you establish between 1 2 as 2 4 and same as 3 4? That is in power format. Here the maximum number of equal pieces, you can establish the relation, that is 2 power n, where n is number of cuts. N is number of cuts. See here, for example, n is equal to 1, then 2 power 1 gives 2. If n is 2, then this is nothing but 2 power 2, 2 square is 4. And if n is 3, here you are getting 2 power 3, 2 power 3 is 8. In the same way, in the real time question, if 6 cuts are used to make the big cube into equal number of maximum pieces, there you can apply 2 power 6. 2 power 6 is nothing but 2 power 8, we know 8 8 is 64 is going to be your answer. This is how, by using the number of cuts, we can find out number of minimum number of equal pieces and maximum number of equal pieces. This is very important rule. To find out minimum number of equal pieces, number of cuts plus 1, to get the number of maximum pieces, 2 power number of cuts. By remembering these two, you can give your solution without any confusion in the minimum time. This is about the number of pieces when a cube is cut into by using number of cuts. And how the different questions may be asked. One question is very important in the competitive examination. For example, there is a cylinder. In cubes we may get any type of solid. There is a cylinder, its dimensions will be given. Say for example, the height of the cylinder is some 10 centimeter and its radius, say this is 4 centimeter, radius is given 4 centimeter and height is 10 centimeter. And melting this, let us take this is a metal cylinder. This is molten and made into small balls, means spheres that made into small balls. Each ball radius is going to be 2 centimeter. The big cylinder whose height is 10 centimeter and base radius is 4 centimeter, that molten and made into very small balls. Each ball radius is 2 centimeter. The question is, how many such balls can be made from this cylinder? So the question will be like this: how many balls of radius 2 centimeter each can be made from a cylinder whose height is 10 centimeter and base radius is 4 centimeter? How are you going to solve this question? So the question may be not only between the cylinder and sphere, the question may be asked like anything. See, another question type is, say there is a cuboid. The cuboid dimensions are given. It is height is 4 centimeter and length is some 10 centimeter and width is some 6 centimeter. And from this cuboid, the small cubes are made. From this cuboid, small cubes are made. Each side is going to be 2 centimeter. Then how many number of small cubes can be cut from the big cuboid whose dimensions are 10 into 6 into 4? This type of question is very, very important. From cylinder, how many cube, how many spheres? From the cube, how many cubes? Like that, any solid to any solid, the number of small solids. To work out this type of question, you need to remember a formula. This is very, very important. So to find number of small solids, any type of solid, small solids, to find number of small solids from given big solid is equal to volume of the big solid, volume of big solid divided by volume of small solid. This is very easy formula to calculate the number of small solids made from a given big solid. This is very, very important. Now let us solve these two questions. Here the first question is, how many small spheres can be made whose radius is 2 centimeter, which are made from a cylinder whose dimensions are 10 centimeter height and 4 centimeter base? So here in this case, your solution is number of small spheres, or number of spheres you can write. Anyway, they are going to be small. Number of spheres is equal to, what do we have to get the number of small solids? Volume of the big solid by volume of the small solid. Here big solid is the cylinder. So volume of cylinder divided by volume of sphere. Then what's the volume of the cylinder? Volume of the cylinder in mensuration we learned it is going to be pi r square h, pi r square h. Here I am taking for the cylinder the radius is capital R. Capital R stands for the radius of the cylinder and small r stands for radius of the sphere. Pi r square h divided by volume of the sphere. What is the volume of the sphere? It is 4 by 3 pi r cube. Here small r stands for the radius of the sphere. Then substitute the values in it. Here pi gets cancels and 3 will go on top, that is 3 into r square. Capital R is 4, it is 4 into 4 into h, h is 10 divided by the 3 is taken up, then 4 into small r cube. What is the small r? Each radius is going to be 2 centimeter. R cube means 2 into 2 into 2, 2 into 2 into 2. Then do cancellations. Here 4 gets cancels. Then 2 to the 4 gets cancels. This is 2 5s. So 3 5s are 15. We get 15 small spheres whose radius is 2 centimeter, which are made from the big cylinder whose height is 10 centimeter and radius is 4 centimeter. This is one question. Let us solve the other question. How many cubes of each side 2 centimeter can be cut from a cuboid whose dimensions are 10 centimeter, 6 centimeter, 4 centimeter? We know that number of cubes is equal to volume of the big solid divided by volume of the small solid. Here big solid is cuboid and small solid is cube. So volume of cuboid divided by volume of the cube. Since we are cutting the cubes from the cuboid, then what is the volume of the cuboid? The cuboid has the dimensions length, breadth, height. Volume we can find out by finding the product of length, breadth, height. So that is length into breadth into height. It is nothing but 10 into 6 into 4. And volume of the cube, each dimension is 2 centimeter. That is 2 into 2 into 2. Then on the cancellations, 2 to the 4 gets cancels and 2 3 times, it is 10 into 3, 30 cubes we get. Volume of the big solid divided by volume of the small cube gives the number of small solids, that is number of cubes which are cut from a cuboid. Given cuboid is 30. We can cut 30 cubes from the given cuboid. Let us see the different type of questions in the cuboid. Just look at the picture. In the real time exam, this type of questions are very, very important. Here in the picture, one cube is given. What is this? It is a cube. Some directions are given. What are the directions? Can you read the directions? Here a solid cube of each side 8 centimeter has been painted red, blue and black on pairs of opposite faces. It is then cut into cubical blocks of each side 2 centimeter. Understanding these directions is very important. In the real time question, one solid, here the picture is given, but in the real time exam you may not expect the picture, only the directions will be given and questions are followed by the directions. So understand the directions irrespective of the figure. You need to visualize there is a cube. The cube has total 6 faces. Only there are pairs of opposite faces. Pairs of opposite faces means 3 pairs we get. The pairs of opposite faces are colored from outside. It is a solid. Outside the opposite faces are colored. According to this picture, here the top and the bottom is colored with red and other 2 sides faces are black, and opposite to you and back side of the cube colored with the blue color. And then after coloring it, when it becomes dry, it is cut into small cubes. Each small cube side is 2 centimeter. This information is given. The big cube side is given 8 centimeter. This is going to be 8 centimeter. When small cube is taken out, collected out, the side of the small cube is going to be 2 centimeter. It is the information provided in the question. Then through this information, the questions are followed like this. The question number 1. The question is, how many cubes are there in all? How many cubes are there in all, in the sense, how many small cubes are there in the big cube? We know how to work out this question. How to work out? Whenever it is the number of small cubes are asked, we know number of small cubes is equal to number of small cubes is equal to volume of big cube divided by volume of small cube. What is the volume of the big cube? The big cube has the dimension 8 centimeter. The volume of the cube is side into side into side, it is 8 into 8 into 8, and volume of the small cube, each small cube dimension is given 2 centimeter, then 2 into 2 into 2, 2 to the 4 to the 8, 8 gets cancels. There are 64 small cubes are there in all. So in our question, how many cubes are there in all? In the sense, there are total 64 small cubes are there. Now let us go to next question. For the same information, how many cubes have no face painted? Here it's very clear, the direction says that the cube colored from outside, the color may not enter inside. That's why only outside cubes which are available externally, those are only painted. And how the paint was done, we know. Only opposite faces are painted with the same colored. As we know, the top and bottom are colored with red. The two opposite sides, left and right, are painted with the black, and opposite to you and back side are painted with blue. Now the question is, how many cubes have no face painted? Only external faces are painted. That's why definitely there should be remain some cubes internal of the cube, inside of the cube. The question is, how many cubes have no face painted? Means without painting, how many cubes are there? Then how can you work out this question? So think logically, you can get your solution. No mass is involved. If you understand the question, then you can give your answer. My idea to work out this question is, first we know the total how many small cubes are there. Out of all the small cubes, if we deduct the cubes which are painted, then we will get the number of faces, number of cubes which are unpainted. So our idea to work out this question is, number of cubes which are unpainted, no face is painted, is equal to total number of cubes minus number of cubes painted somehow. Total number of cubes minus number of cubes painted somehow. So what is the total number of cubes we have? That is 64. Minus, only thing is we need to find how many cubes are painted somehow. From this picture we can clearly notice that we can find out how many cubes are painted. See, first my idea is taking this black. If we take this black, this total black is painted with the black color. So how many cubes are there in this block? I am taking out this complete block out from here. I am taking out totally outside. How many cubes are there? 1, 2, 3, 4. 1, 2, 3, 4. 4 4s are 16. These 16 are painted other side, that side with black. So here 16, and I am taking this also. This is disconnected from this big cube. So here 16 and here 16. Total 16 plus 16, 32 are painted. Plus, now when this is detached and this part is detached, we are left with only this part. So in this part again we are going to detach the colored faced cubes. Now let us take the top ones. Top ones, these are colored with the red. How many are there? 1, 2, 3, 4 and 1, 2, 3, 4. Here 8 are there. Even the same thing here, base this part gives the 8. Here 8 plus here 8. Total 16 are painted top. We detached the right side part completely and left side part, and top and bottom detached. Now what is left here? We are left with only exactly in the middle 4. This is towards you, which is front view. In front view it is painted by blue. That's why these 4 faces are painted by blue, and back side also 4 cubes painted by blue. So front view and back view, 4 plus 4, total 8 are painted. So plus 8. Now this is going to be 64 minus these all number of cubes which are painted somehow. It is 16 plus 8, 24 plus 32, it is 56. So 64 minus 56, it is going to be 8. 64 minus 56, 60 minus 54 plus 4, 8. Yeah. So 8 cubes are unpainted. So in our question, how many cubes have no face painted? It is going to be C, your answer. So 8 cubes are unpainted, which will lies in exactly at the center of the cube. Let us take another question. What's the other question? How many cubes have only one face painted? How many cubes have only one face painted? One face in the sense where it lies only one face painted. Just let us see taking the random cubes in it. If we take this front view and taking this corner cube is painted front view and this right side view and the bottom also. So this is painted 3 faces. Here we require only one face. For example, if we take this cube, it is painted front view and right side view. Right side view painted by black and front view painted by blue. So this is painted 2 faces, but we require only one face. So if we take this cube, here this cube, this has only front view, it is painted by blue. That's why we get only this cube painted only one face. So how many such cubes are there? 1, 2, 3, 4. These 4 cubes are painted only one face. That is only in one face. The cube has total how many faces? The cube has total 6 faces in all. In one face, we find 4 cubes are painted one face. In one view, there are 4 cubes, such that total 6 views are there for a cube. So 6 4s are 24. So 24 is going to be your answer, which only one face painted. Is it clear? One face painted means only this becomes 1, 2, 3, 4 are there in front view. In the same way, back view 4, top view 4, bottom view 4, left view 4, right view 4. Total in 6 views. In each view 4, 6 4s are 24 is going to be one face painted cubes. 24 is going to be right solution for your question. Let us take another question. How many cubes have only 3 faces painted? Observe carefully which cube is painted only 3 faces. It is very clear, only the corner cubes are faces, only corner cubes are painted 3 faces. Let us take this corner cube and observe where it is painted. Here this side means right view painted by black, and this is the front view painted by blue, and top view it painted by red. So this is the cube which is painted 3 faces. So the 3 faces painted cube is available only at the corner of the cube. So how many corners a cube has? We know that a cube has total 8 corners. Corner 1, corner 2, corner 3, corner 4, and back side 4. Here front view 4 corners and back view 4 corners. Total 4 plus 4. 8 cubes we get, which are at 8 corners. So your answer is going to be 8. So how many cubes have only 3 faces painted? 3 faces painted we find only at the corner. Since a cube has 8 corners, we get 8 cubes are painted in 3 faces. Let us take another question. How many cubes have 2 faces painted red and black and all other faces unpainted? It seems to be very difficult, but by visualizing, trying to understand where it is painted and how, you can answer to this question easy only. Here we require 2 faces painted red and black. So a cube, one face painted red, other face painted black, and other faces are unpainted. So focus where the red color is painted. In this case, the red color is at the top and bottom. The cube painted by red on the top and bottom. And one more thing is black. Black is only the right view and left view. So we have to take the cube which is painted only red and black. Now observing this corner cube, front view painted with blue, that's why we cannot take. Now if we take this two cubes. The top is painted with red and this right view is painted with black. We require the same thing. Two faces, one is by red, other is by black. So here this is the cube painted red at the top and right view painted by black. This is the cube which one we require. So here this is the one cube and this is the one cube. Two cubes are there at one edge. At the top one edge, two cubes are required cubes. Here on this edge two are there and this side edge also two are there. So 2 plus 2 4. At the same thing here bottom, these two and other side 2. So 2 plus 2 4 and bottom 4. 4 plus 4, total 8 cubes are required cubes. So answer B is going to be your right option.